Okay, so today what we want to have a look at is rational indices, so that is fractional indices. And we want to have a look at experimenting with what we know, so trying to identify some patterns that will enable us to work out what the fractional powers mean. So let's think about filling in these gaps here, just to identify those patterns. So 2 to the power of a half all squared, we know when we have this pattern we can multiply those together. So that's the same as 2 to the power of 1, which is 2. So what we're saying here, if we're trying to work out what does 2 to the power of half mean, is we're essentially saying, so we're trying to work out what does that mean. We're essentially saying, what do we have to square to get 2? And we know that we have to square root 2 in order to get 2. And so therefore, the only way that that can be true is if 2 to the power of a half is the same as the square root of 2. 7 to the power of half all squared is 7 to the 1, which is 7. So something squared equals 7. We know that's root 7 squared equals 7. And so therefore, that tells us that 7 to the power of a half has to be the same as root 7. 9 to the power of a half squared is 9 to the power of 1, which is 9. So what squared equals 9? We know 3 squared equals 9. That means 9 to the power of a half equals 3. Which means that it must be the square root of 9. Okay, again, 16 to the power of a half squared, multiplying those together, 16 to the 1, which is 16. So we're saying, well, okay, what squared gives me 16? And we know that that is 4 squared gives me 16, which means that 16 to the power of a half must be the same as 4. And we know that 4 is the square root of 16. So x to the power of a half must be equal to the square root of x. Now that's by no means a proof. We're simply looking at the established patterns with various numbers and therefore able to draw a conclusion that it seems that x to the half is equal to the square root of x. We could think about the same pattern with the power of a third. Okay, 2 to the power of a third all cubed is 2 to the power of 1. We multiply those powers, a third times 3 is 1, which is 2. So here we're learning that something all cubed equals 2. Something all cubed equals 2. Right, we know that if we want to cube something and get 2, we can cube the cube root of 2. Okay, so 2 cubed is the cube root of 2. Again, 8 to the power of a third and then cubed, a third times 3 is 1, so 8 to the 1, which is 8. So something all cubed gave us 8. Okay, so let's try and think that through. What cubed gives me 8? I know 2 cubed gives me 8. So that means 8 to the power of a third must be equal to 2. 2 is the cube root of 8. Okay. Again here, 27 to the power of a third and then cubed is 27 to the power of 1, which is 27. So what we're seeing here is that something cubed gives me 27. We know that something 3 cubed is 27, and so therefore that means that 27 to the power of a third must be equal to 3, which is the cube root of 27. So x to the power of a third is the cube root of x. So generally speaking, x to the power of 1 on n is the nth root of x. Okay, let's think about non-unit fractions. So if we had, rather than just 1/3 or 1/2 or 1/4, we have 5 halves in this case, 5 on 2. So we want to be able to think about this as 2 separate powers. So we could think about this. We know that 5 on 2 is 1/2 times 5. That's what 5 on 2 is. And we know that we multiply powers when we are applying them one after the other like this. And we now know that 25 to the power of a half is the square root of 25. So we actually have 5 to the power of 5. Whatever that is. 5 cubed is 125, 625. So it's going to be 3125, I think, off the top of my head. Sorry, you can check that. I'm not too worried about the actual value so much as the simplification. Okay, 49 to the power of 3 on 2. So again, we can think about that as 2 separate powers. It's 49, 3 on 2 is half times 3. So this is 49 to the half, and then cubed. Now, note, you could also think about it as 49 cubed and then to the power of a half, but I don't know what 49 cubed is. That's massive, and then I'm going to have to know what the square root of that massive number is. So it's always easier to apply the fractional power first, make the number smaller, and then make it bigger with the whole number power. Okay, so this is square root of 49 cubed. Square root of 49 is 7. 7 cubed is 343. 8 to the power of 4 thirds. Okay, so we've got 8, so it's 1/3 times 4. So it's 8 to the power of 1/3, and then that to the power of 4, which is the cube root of 8 to the power of 4. So 2 to the power of 4, which is 16. 27 to the power of 2 thirds. It's 27 to the power of 1/3 times 2. So it is 27 to the 1/3 squared. That is the cube root of 27 to the power of 2. 3 squared, which is 9. Now, negative power just means it's all happening on the denominator. So this is 1 over 32 to the power of 2/5. 1 over 32 to the power of 1/5 times 2. So it's 1 over 32 to the 1/5 and then squared. 32 to the 1/5, the fifth root of 32. What to the power of 5 gives me 32? It's 2. So we have 1/4. So we can generalize x to the power of m over n, because it is x to the power of 1 on n times m, which is x to the power of 1 on n all to the power of m, and so we get the nth root of x and then to the power of m. Note it could also be x to the m times 1 on n, which would be x to the m to the 1 on n. So you can also think of it as x to the m, the nth root of x to the m, but usually the top version is easier. It is easier to make the number smaller by using the root first and then make it larger. Okay, let's evaluate each of the following. Apologies again. Alright, so 16 to the power of a half. Power of a half means square root of 16, so this is 4. Now it's not plus or minus because you're not taking the square root. If it meant minus 4, it would be negative 16 to the power of a half. Okay, in the same way that if I meant negative root 2, I would write negative root 2. If I just write root 2, I mean positive root 2. It's the same idea. So this is positive 4. 27 to the 1/3, it's the cube root of 27. You really don't need to write out the step with the cube root. Understand it means cube root. Cube root of 27 is 3, because 3 cubed is 27. 64 to the power of a, sorry, that's not right. That's not going to work. Can we make that a power of a third? Or let's make it, let me change that question. Let me make it, yeah, let's just do it 16 to the power of a quarter. Okay, so that is the fourth root of 16, and that is 2, because 2 to the power of 4 is 16. This is where you really need to know a lot of those powers. Know your powers of 2 up to sort of, 2 to the 6, 2 to the 7, 2 to the 8 even. You can generate the powers of 2 pretty quickly. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. I'm just doubling. That's what powers of 2 are. So it's easy enough to generate them. Certainly, powers of 3, 3 cubed is 27, 3 to the power of 4 is 81. So sort of knowing your powers of small numbers up to kind of 4, 5, 6. Okay, 4 to the power of 3 on 2. Okay, so thinking about this as being 4 to the power of a half, and then cubed. So it's the square root of 4, which is 2, cubed, which is 8. Again, thinking about this as 8 to the power of 1/3 squared. So cube root of 8 is 2 squared, so this is 4. 81 to the power of 3/4, so it is 81 to the power of a quarter, and then cubed. The fourth root of 81 is 3. 3 to the power of 4 is 81, so it's 3 cubed, and therefore 27. Alright, 8/27 to the power of negative 1/3. So the negative power means I can take the reciprocal of my base, so it's 27 over 8 to the power of 1/3, which means it is 27 to the 1/3, or the cube root of 27, over 8 to the 1/3, or the cube root of 8. So cube root of 27 is 3 over cube root of 8 is 2. So it's 3 on 2. Right, example 2, express as powers of 5. Okay, so 125 is 5 cubed, and then we've got the square root of that, so that's a power of a half. So this is 5 to the power of 3 on 2, multiplying 3 times a half. Okay, 25 is 5 squared. Cube root of 5 is 5 to the 1/3. Subtracting powers when we divide, this is 5 to the 2 minus 1/3. 2 is 6/3, take away 1/3, so it is 5 to the 5/3. Example 3, express with a prime number base. Okay, so 32 is 2 to the power of 5, and 2 is a prime number. So we've got 2 to the 5, and it's the cube root of that, so that's a power of a third, so it is 2 to the power of 5/3. 27 is 3 cubed, 3 is a prime number being a number divisible by 1 and itself, only 1 and itself. So 27 is 3 cubed, and we're square rooting that, so that's a power of a half. So this is 1 over 3 to the power of 3 on 2, which means that it is 3 to the power of negative 3 on 2. Right, simplify expressing your answer with positive exponents. So x to the 2/3 divided by x to the half. We know when we're dividing powers with the same base, we subtract the exponents. So 2/3 minus a half. To subtract fractions, we need common denominator, which will be sixths in this case. So that is 4/6 minus 3/6, and so it is x to the 1/6. Alright, let's first deal with the brackets. So we've got 125 to the power of a third times n, and so we multiply powers. Negative 6 times third is negative 2. 125 to the third, that's the cube root of 125, which is 5, n to the negative 2, expressing with positive exponents, so 5 over n squared. Alright, C, 32, so we're expanding the brackets first, so we've got 32, to the power of 1/5. E to the 5 to the power of 1/5, so multiplying 5 by 1/5 is 1. And f to the 10, and then to the power of 1/5, so multiplying 10 by 1/5 is 2. 32 to the power of 1/5, 5th root of 32 is 2. E to the 1 is just e, f squared. Alright, and then here we have got 16t to the 8, and then all that to the power of a quarter. So it is 16 to the power of a quarter, and it's going to be t to the power of 8 times a quarter, which is 2. 16 to the power of a quarter is the 4th root of 16, which is 2. So we have 2t squared. Alright, simplifying each of the following. Now, if you want to, you could say, let a equal 2x plus 1, and see this as being 1 on root a times a cubed. Simplify that, and then put 2x plus 1 back in at the end. Perfectly fine with that, okay? I'm going to leave it as it is. I'm going to have, so we've got square root of 2x plus 1 times 2x plus 1 cubed. Let's be clear about the fact that that's the same as 2x plus 1 cubed over the square root of 2x plus 1. They don't need to be written separately, okay? So you've got 2x plus 1 cubed over 2x plus 1 to the power of 1/2. Same base, 2x plus 1. We subtract the powers, so we're going to have 2x plus 1 to the power of 3 minus a half, which I know is tempting to write as 2.5, but I really don't want a mixed number up there. So 3 is 6 on 2 minus 1 on 2, which is 5 on 2. So 2x plus 1 to the power of 5 on 2. Okay, so you've also got some work on fractional indices. So if you it looks like about every second part possibly of question 1, question 2, and then a couple of parts from question 3.